Hello, I'm Sophia and I welcome you to Sophia Explains, where curiosity leads the way. You, me, our planet, our galaxy, everything started 13.8 billion years ago. But mind you, there wasn't an explosion, it was the expansion of space itself. Today, we are going to explore one of the most fascinating events in science, the Big Bang. When we hear the words Big Bang, we tend to imagine a giant explosion that created everything. But that's not quite correct, because the Big Bang was space itself expanding, and that expansion is still happening today. Let us travel back 13.8 billion years ago. During the earliest time, space was extremely small, dense, and unimaginably hot. Then we enter the Planck era, which lasted about 10 to the power of negative 43 seconds. This is the earliest moment physics can currently describe. The universe was smaller than the size of an atom and hotter than anything we can ever imagine, with temperatures around 10 to the power of positive 32 degrees. That's a lot, truly. During this time, the four fundamental forces, gravity, electromagnetism, strong nuclear force, and weak nuclear force, may have all been united as a single superforce. Now comes the grand unification era. The universe continued expanding and cooling, and gravity separated from the other superforces. But still, the universe was still with extremely energetic quantum fields. Then, something extraordinary happened. In an incredibly tiny fraction of a second, space stretched faster than the speed of light. Yes, you heard me right. Space stretched faster than the speed of light. The universe expanded enormously, becoming smooth, flat, and vastly larger. After inflation came the electroweak era. The universe cooled enough for the strong nuclear force to separate from the electroweak force. Energy started converting into particles such as electrons and quarks through a process known as pair production. Then came the quark era. When the universe was about 10 to the power of negative 6 seconds old, the universe was filled with an extremely hot soup called quark-gluon plasma. Quarks, the building blocks of protons and neutrons, floated freely along with gluons, electrons, photons, and neutrinos. The temperature was around 1 trillion degrees. We finally arrived at the particle era when the universe was about 1 second old. By this time, the universe had cooled enough for quarks to combine into protons and neutrons, and the weak nuclear force separated from the electromagnetism. Now, the four fundamental forces existed independently just like they do today. But still, the universe was opaque. Photons could not travel freely because they constantly collided with charged particles. This marks the end of the very first chapter of our universe's story. But the journey is far from being over. In the next stages, atoms will form, light will finally travel, and the first structure of our cosmos will begin to emerge. Keep asking questions and never stop being curious. Till then, farewell and thank you for watching.